This is an Astor DLP mantle radio from 1956. It's an interesting set because it's only got two valves in it and it's a superhet. The cabinet is held together by two, or should be held together by two metal clips which are missing. Instead it's had self-tapping screws to substitute for that, which is probably the best way to do it. But yeah, the plastic's broken around where the clips are, so that probably wouldn't be any use anyway. Inside it we see a few unusual things. Firstly, the thing which stands out the most is the chassis sloping down the cabinet, and the reason for doing that is because the set is permeability tuned, as we can see here with the cores going in and out of the coil formers, and that's mounted right on the chassis. So to keep the tuning knob central to the front panel, yeah, the chassis has to be mounted up here. And because we have a tall valve there, it has to slope down. It's a real cost-cutting set. I mean, you can see that. The power transformer is one of the smallest I've seen in any mantle radio. It has a selenium rectifier here. The converter valve is a 6BE6, the one and only IF transformer is there, and the 6BM8 is the detector and audio output valve. And as you can see on the transformer there, the transformer was dated 13th of November 56. The speaker is a Roller 5C, and it's been attached to the front of the cabinet with the speed clips on plastic studs, which is another sign of cheapness. It's been recapped, so it's going to save me a lot of work. Just a bit of background to this set. It's from a fellow HRSA member, and he got it from yet another HRSA member. And the reason I ended up with the set is in response to another YouTube video which showed this set in a rather unfavourable light, so we thought this was a bit odd. And I'm sure, you know, the set should perform a lot better than it was made out to be, so what better way than to, you know, get one of these sets and actually go through it. But my experience here, 60 kilometres away from the stations, is that it should put in a reasonable performance, even though it's missing an IF amplifier. So that's an overview of the set physically, and I'll just move the camera over and we'll have a look at the circuit diagram. Starting with the frequency converter, the 6BE6 pentagrid valve. It's completely conventional except for two things. Firstly, there's no AVC in this set, so the gain or volume is controlled by the cathode bias through this 25k potentiometer. So at low volume the full resistance is in series with the cathode, taking it almost to cut-off, and at the same time the aerial input is shunted to earth, and there's an 8.2k across the pot to limit the resistance. So at full volume the only resistance in series with the cathode is the 330 ohm, which sets the minimum bias, and instead of being shunted to earth there's only 25k across the aerial input, in parallel with the 47k there, of course. Now, as before, I explained it's permeability tuned, so it looks like a car radio electrically. And one of the important things to note with circuits like this with permeability tuning is that the aerial actually forms part of the capacitance of the tuned circuit. So that's why the aerial length is actually critical with this set, and it is specified that it's 25 foot of wire, and that supposedly is meant to represent about 200 picofarads. So when you're lining it up with a signal generator, put a 200 picofarad capacitor in series with it. And if you use, other length aerials or whatever, it will upset the alignment of that and it won't track with the local oscillator. So in the usual way, the 455 kilocycles appears across the primary of the IF transformer. So the local oscillator modulates the first grid of the valve, so it's modulating the whole electron stream, and the incoming signal is also in that path. So we're modulating the RF input signal, which is going to be somewhere in the broadcast band, 530 to 1600 kc, and that's modulated by the local oscillator, which is running at 455 kc above that. So one of the products we get at the plate at pin 5 is the input frequency converted to a fixed 455 kc. Okay, so the next thing is the detection, seeing as we've got no IF amplifier. At first glance, this looks like a grid leak detector, but it isn't, because if we look at the component values here, 10 meg and 0.01, that's actually a very long time constant, and that would filter out the audio. Normally in a grid leak detector, the grid resistor would be about 1 meg or 2.2 meg instead of 10 meg, and the capacitor would be about 100 to 200 picofarads or thereabouts. But in this instance, what's happening is the valve is actually operating more like an anode bend detector, because it's a high mu triode, and that means that if you have a very high value of grid resistor, the grid will actually charge up to a slight negative voltage. It's a fraction of a volt, but it's all you need. And you would have seen circuits like this with 12AX7s and that kind of thing in audio circuits where there's no cathode resistor and they're just relying on the contact effect bias, or contact bias I should say. So basically when it's presented with RF, on one side of the cycle it's going to take the valve more into cutoff than on the other side. So there's a non-linearity here, provided the signal is strong enough, of course. So with audio at the plate, that is then passed on to the 6BM8 pentode output stage. The plate load is 0.47 meg or 470k if you prefer the modern way. RF bypassing is by the 0.003 capacitor, so it's a fairly steep roll-off actually. 3000 picofarads versus 470k. That's a fairly severe cut-off actually. There's a 100k grid stopping resistor on the pentode, and that operates with the grid to cathode capacitance to form a low pass filter, just for stability. Not that I would think a circuit like this is going to have enough gain for the pentode to start oscillating, but anyway. There's further RF filtering, stability, tone control if you like, with the 0.01 across the speaker transformer. The 6BM8 is biased through a back bias circuit, the 270 ohm in the negative supply line. One of the unusual things about this power supply is that the high tension is only 96 volts, which is very low for a mains powered radio, and I can only assume they've done that to reduce the amount of winding required in the transformer, to cheapen it, you know, save the copper costs. And there's the selenium rectifier. Note that it's only half wave rectified, which is another cost cutting thing. In a normal set, if you like, that would be a full wave rectifier, probably using something like a 6x4. And looking at the set here, this is the selenium rectifier as I showed before. It's got two silicon diodes across it, which are probably General Electric A14Ps or something like that. That's what they look like. And it's puzzling that, well, someone has done that obviously to compensate for a defective rectifier. There is here what looks like a 3 amp diode 1N5408 or something like that, which has been put in its place. So it's curious why that's been done, and this has been taken out of circuit. I can only assume this might have broken down to earth or something. But anyway, with all that explained, next thing to do is power it up and see what it does. I've connected a capacitor in series with the aerial. I've set that to 200 picofarads. So plug it into the 240, and I'll just have to turn the power on. Okay, valves are warming up. Let's see what it does.
Applied to protest from the Jewish side of this. Well, what does Pine Gap do? Pine Gap does.
Okay, so that's 2FC.
It's a control down,
which is 50 kilowatts.
Of the AC investigation.
But yes, there's
It's news radio.
well a lot of the pro-Palestinian
It's
protesters
TBL.
and all.
Why couldn't they defend themselves today? They could have. They were there. They could have said, no, we disagree with Liverpool Council. This is urgent.
It's
We
2
need to support
GB.
it. We cannot have
Now
an
this
election.
is the
We
volume
need an
full on.
administrator. They weren't even.
It's interesting, there's traces of 2LT there. 2UE,
Reserve Sir Jody Lord
2KY.
with
It's 2EA.
that story secondhand. I hope it's true, actually.
I think
'cause
that's
it's a nice little,
SEN, which is the old 2CH.
Number so that our listeners
2RPH.
can find out more.
And it's 2SM. So it's actually not that bad. But I'll see if I can get a bit more out of it. Yeah, look, in the metropolitan area, it would probably work reasonably well. I'm about 60 kilometres away from the stations. This one here at 2UE is 5 kilowatts, 58 kilometres away, so yeah, it's a lot better than I think it was made out in the other YouTube video. Although it's been recapped, it's still got all the original IRC resistors in it. So we'll have a look at those, because because they're always suspect, and these days most of them are out of tolerance. So let's have a look and just see how they are. So 22k grid leak on the 6BE6, that's 26, it's alright, you can live with that. It's 47k resistor, that's 54, that's the aerial input static discharge resistor, that's not critical. The 18k dropping resistor for the converter valve screen, that's up to 23. Now bearing in mind we're running at such a low high tension, this resistor high is not going to do it any good, so I'll change that one anyway. The 470k plate load for the detector, well, that's almost 100k higher than it should be, so that'll have to go. What have we got here? The 470k grid resistor for the 6BM8 Pinto, that's up a bit. We've got 330 ohms here. Okay, well that's up around 407 ohms. Oh yeah, that's the yeah. Well, see, that resistor, the 330 ohm, is actually the bias resistor for the 6BE6. So already we're 100 ohms higher. So that's an automatic loss of volume. Okay, so that's got to go. And there's 270 ohm back bias resistor down here. Yeah, that's up a bit more. That's reading about 304 ohms. So that's over biasing. That's that resist here. So that's over biasing the 6BM8 even more. I mean, normally it wouldn't be so critical, but given we're running at such a low high tension voltage, any further reduction in voltage is going to only make things worse. So I'll re-resistor it, and one of the other things I want to do is tidy up this. There's no way this needs to be 450 volts, and also it's 100 microfarads, which is much more than required. So I think I got a 150 volt capacitor I can put in its place to tidy that up, and that spring strip here should actually be on the inside of the shield for better earthing. So I'll do all of that, and we'll see what happens, see if it's any better afterwards. I've started re-resisting the radio, and whilst doing that I thought I'd tidy up the connections to the replaced capacitors, because they'd just been dabbed onto the original solder tags and everything without removing the old wires, which had just been cut off. And in that process I have discovered that well, most of the capacitors are actually different values to what's on the circuit diagram, which is interesting. And some of them would have quite a marked effect on the performance. In particular, the one that really stands out is the plate bypass for the detector triode, which according to the circuit should be 0.003 or 3000 picofarads if you like, but in its place is 0.015, and that with 0.47 meg is going to have an incredibly low frequency roll off. in fact, yeah, it's a wonder anything was audible at all, really. Another capacitor is the grid coupler to the 6BM8 pentode. Instead of 0.002, it's 0.001, which will have the effect of reducing the bass response somewhat, but somewhat paradoxically, actually lowering this capacitor will actually offset to a small degree the increasing of the plate bypass. Also, the 0.01 across the speaker transformer is 0.0033. It's odd that the previous restorer actually didn't use that capacitor over there. The grid coupler for the detector is 0.015. I think the restorer had lots of 0.015s actually. Instead of 0.001, that's not going to make much of a difference, but I like to keep the radio as per the design. And this capacitor down here, the 0.02 for the oscillator coil coupling, was also another 0.015 instead of 0.02. Again, look, it's probably not going to make much difference. I'm reinstating the original selenium diode with the silicon diodes across it, just for authenticity. The 0.5 bias filter capacitor here was 0.1. Again, look, the radio will work, but 0.5 will get better hum filtering. So after I've done all of that, it's going to be very interesting to see how the radio sounds.
I'll be right here if you should call. This is how they are. And you know, wherever I am. Tackle and surely the halftime siren sound. Action just to end this opening goal square.
Sort of
The whistle. American Son and also Ben Ahmed.
I'll repeat here.
Their side. And I
It's hard to overstate this. You're on a house? Okay.
tackle it on this.
So it's got new resistors, new correct value capacitors in it, and it's made a hell of a difference. It's not a bad performer actually, and I'll just show what I've done. So as I said before, the selenium rectifier's gone back in circuit, but the silicon diodes are still required because the original rectifier is actually open circuit. And looking in here, as you can see, it's a lot tidier, and I've done the alignment of the local oscillator and the aerial. The only original resistors left is the 22k oscillator grid leak, the 100k 6BM8 pentode grid stopper, the 8.2k which limits the volume control, and the 47k static discharge resistor. I've also put back the original 24 microfarad can electrolytic. That keeps the chassis a bit tidier. As I thought, there was nothing wrong with it. I mean, these Ducon can capacitors, or actually all the Ducon electrolytics, are very reliable. So it's no problem. And yeah, I mean, I would say that this radio is far from a piece of junk, as has been described elsewhere on YouTube. Anyway, that is the Astor DLP.